This is question 11A from 2.3, and I'm Emily also.
I'm Sam.
Ruby. All right. On this question, we are dealing with a home buyer who wishes to borrow $250,000 at an interest rate of 6% to finance. We are assuming that the interest is compiled continuously and that the payments are also made continuously. And we're interested in part 11A, which is determining the monthly payment that is required to pay off the loan in 20 years.
So our initial borrow amount is $250,000. And we'll just set that equal to C initial.
So what does C represent?
C represents the initial borrowed amount that we're taking out for the loan. And the percent, the rate of interest is going to be 6%. So I'm just going to quickly convert that into decimal.
Perfect.
Decimal form, which is 0.06.
Do I get to like?
Then we're looking for the monthly payment in time and years. So we want 20 years.
And yeah, so our T final will be 20 years.
So let me ask you, when you read the question, the part A, it asks us to find the monthly payment. So are we making the payments yearly or are we making the payments monthly?
Monthly. We are
So
making
if-
the payments monthly.
So we're going to cross this out and just change it to months real quick.
And if it is 20 years, how many months would that be?
That would be 20 times 12. So we're going to just do some units here. Oops. 12 months
So like 240.
per year. Yeah, exactly.
Excellent.
It's 240 months.
Okay, so now we just need an equation.
Let me ask you, Emily, what was the thing we're trying to find in this question?
We're trying to find we're trying to determine the monthly payment that we have to pay it off in 20 years.
Okay, so see, I'm trying to get all of you kind of talk, so I didn't call you by name. So, and how do you think we can represent the monthly payment in this case?
I guess we can represent in the.
We could just make it another variable P.
So we don't have it yet, so.
Yeah.
So I'm ready.
Sure. Yeah, sorry, you go for it.
Okay, so I guess P is the monthly payment. And then that would just be P over T, right? Wait, never
Well,
mind.
let's, Corey, we will get there, but let's leave it as what it is. What other variables do we have in this question, Ruby?
Well, other than what's up there right now, let's see, well, we have the payment and the interest rate and the fact that it's compounded continuously.
What is compounded continuously?
The interest rate is.
Okay, so if it gets compounded, where does that interest rate get added to?
It is going to get added to the total. So
Okay, so
the total is also going to be a variable then.
Excellent. So what should we call that one?
Can I
Maybe
just
just
change, maybe
C?
if I change this to like loan initial, and then you can see.
Like C equals amount owed.
Yep.
Or amount remaining.
So kind of the account balance? Sorry.
Okay, we can do that. Account balance. All right. Should we leave that as C naught or does it matter?
It doesn't really matter once we get the equation going. So, yeah.
Do you all agree on that? So it doesn't matter if you're representing the balance by L and C at the same time?
I would kind of want
You want it all in C?
maybe.
Sure.
It's
It ends up
If
that these are
three
just
of you
variables. They just represent these numbers. So
So if three of you agree on that, then we can change it. It's up to you.
Yeah.
I don't.
do you want it in C?
Sure.
Sure.
Just-
All right, we'll put it back to C. Let's just cross this guy out. Make it back that. So again, this is our initial
Initial
Amount.
value.
borrowed right here, which is
Okay.
250,000. So now we should try to write an equation for this.
Okay, so, let's see, so, let me ask you this. So the question wants us to find the monthly payment, correct?
Mm-hmm.
Mm-hmm.
And that monthly payment, it means we are making a payment on the loans on monthly basis, correct?
Mm-hmm.
So let me ask you this, on monthly basis, how do you think the account balance is gonna change?
It will be like 250,000 minus PT. Right?
Mm-hmm.
Okay, so, correct, so that's one way to construct it, so, or, what do you think when we talk about the rate of change of the account balance, how do we represent that? Emily, you're correct. One way to solve this, like algebraically, you're absolutely correct, that's how you construct it. And then every month you get added interest, and then you add that to the original amount. But I want us to see if we can use differential equation to our benefit. So when we say, like when you make this monthly payment, and how does the account balance change? What would be the rate of change of account balance? Like what would be the rate of change of, in this case, you're calling it C. How do we represent that? How do we represent the rate of change of C?
DC over DT.
Yeah.
Do you agree with that?
That's how it changes over time.
Yeah, I think so.
Okay, so Emily, can you write DC over DT? Thank you. Okay. So, as you said, so we are making these monthly payments, so this rate of change depends on two things. So one thing is, as you mentioned, was the monthly payment. So that rate of change is equal to, how do we represent monthly payment?
P.
Okay, so if the, and what else get added? Because we are getting interest, correct?
Mm-hmm.
So, but the interest you wrote up there, that's 6% per year, isn't it?
No, it's compounded continuously, I believe.
Right.
Uh-oh.
But they usually is represented as annual percentage rate, so.
Okay.
So if you're making monthly payment, that means like continuously monthly, we're gonna get interest added to our account. How do you think, if that's 6% per year, how can we calculate it to find the interest rate per month?
Maybe we could do P divided by 12
Excellent, so,
to current years.
or, well, P divided by 12, you think?
P
Well,
times
no.
12. Because this is a monthly.
Right, so that gives us like how much payment we make in a year. But if we were to calculate the rate for the
Maybe
whole year is 6%.
C times R over 12,
Okay,
the amount remaining times the rate over 12.
okay, so, correct, so the R divided by 12 gives us, because this is 6% for the whole year, so that means every month that it gets added, it needs to add up to 6%. So, correct, if you divide R by 12, that gives you the interest rate per month.
Okay.
So, what would be the interest rate per month?
0.06 over 12, which is,
0.005.
Okay,
Should I write it?
good job.
so go ahead, read it, yeah.
Interest rate per month
Read it.
would be
0.005.
0.005, which was just 0.06 over 12.
Okay.
So that's how much, so if that's the interest rate per month, how much money get added to the account? How do we represent that?
Well, that's going to be times C, right?
Okay. What do you all think?
So C is the amount remaining. This is our initial amount that we put in. We're gonna add the interest rate on this because it's the initial amount.
Correct. So when we look at the rate of change at an instant, you're correct. So eventually we get there. But when you look at the change of the account balance like every month, there are two things that are behaving here. So there is one thing that it get added and there is one thing that goes away. So what are those two things? So as you all mentioned, there's a monthly payment. So in relation to the account balance, what does the monthly payment does?
Brings it down.
Brings it down, it takes it away. But what else get added every month?
The interest.
And how do we calculate? Correct. So, and how do we calculate how much money get added to the accounts every month?
Oh, it's what's in C. C times the interest.
Correct. And how would you represent that?
Uh,
So the rate of change of balance is equal to two things, like the interest that get added monthly, and also the monthly payments that we make on the account balance. So what Emily had like DC DT, that kind of show the rate of change of account balance, but that's equal to two things. Can you figure out what those two entities are?
It's gonna be P. It's gonna be negative P and
So
C.
Okay. Sam, can you write,
Yeah.
negative,
or Emily, can you write negative?
so negative P times
C. Or plus C.
plus C.
I think so.
What do you think? Emily, what do you think? Is it C?
Maybe it's not.
Because C
What
is
in-
the account balance, correct?
Oh, it's
It could
RC.
be-
It's or well, not R anymore. It's what we made it over there.
So plus RC.
No, what do you think, Emily?
I think we should include the initial amount, right?
Initial? Yeah.
Okay, so, correct, you're correct, if we were gonna construct the algebraic equation. Sam, when you talked about interest rate be divided by 12, not Sam, sorry, Ruby. When you talk about interest rate be divided by 12, what that gives us?
That just gives us the rate per month
Rate per
that we're
month, okay?
paying. So that needs to be multiplied by the amount remaining, right?
Excellent.
So what you're looking for is 0.005C
Very good.
as the addition, which is essentially what she wrote. We just need to rewrite R as 0.005 to make that correct, right?
Just cross this out.
But
No,
you
the-
better to have it here,
Very good.
0.005C.
Okay, very cool. What do you all think? Would that give us the rate of change of account balance every month?
Yeah.
I think we
Should it be,
we should include the interest rate.
That's what the
That is the
0.005.
interest rate.
Yeah.
do we
Right,
want
you're
to work
absolutely
C
correct.
naught in
There should be
somehow?
interest.
C naught isn't gonna change
We don't want to start that in there? Doesn't matter?
because it's. But maybe. It's
Okay, let me ask you this. You're going like 2 steps ahead. So what you just wrote, that DCDT,
Mm-hmm.
can you talk about that a little bit? What is that?
So it's just the change of the account balance over time, and it's
Which is equal to?
it is equal to negative P plus 0.005 times C.
Okay, and can you talk about what each one represent? What does P represent and what does 0.005C represent?
P represents the monthly payment, so you're subtracting money because you're paying, and then plus the interest rate per month, which is R divided by 12, so you get 0.005. And since interest rate is based on the account balance, you multiply it by C.
Okay, so going back, Ruby, what was the question asking us to find?
The question was looking for what is the monthly rate sorry, hold that thought. What is the monthly payment we have to do to pay off in a time of 20 years? So we decided that was a time of 240 months.
Okay, so after 240 months, what happened to the account balance?
We want it to be 0.
Okay. So let me ask you, the equation that Emily just described, what does that represent? What do we call that?
A differential equation.
Okay, very good. And so you have the differential equation, but you want to find the monthly payment, the P, in a way that makes the account balance 0. Do we have an equation for account balance?
It is C. That's the variable, that's not the equation.
How
We
do you
can find it. We can find it over here. What you gotta do is,
Sam, what do you think?
here's what we're gonna do. We're gonna subtract this onto this side. So we'll come down here. We'll end up getting dc over dt minus 0.005c equals negative p. I guess that's capital here. And from here, basically, we can just call this C, that thing,
Prime.
prime,
That's one way to correct. That's one way to solve it.
right?
Can you think of other ways to solve it? Emily, what do you think?
I guess you could introduce an initial condition.
Correct. Eventually, you're absolutely correct. We will use the initial condition, but so Sam is proposing that we use, if we write the equation in that form, we can solve it using the perfect product rule of the differential equation. But can you think of other ways that might be simpler to solve this differential equation?
U of T.
Right, yeah, you'd,
So,
from here, you'd find, you'd multiply out a common factor, which here we'll call mu of t. And that will be equal to e to the integral of this guy right here, which is negative 0.005 dt. And through integrating here, we can see that this equals e to the negative t, or sorry, e to the negative, let me cross this out, I'll just cross all of that out. It's going to be e to the negative 0.005 t, since the integral of negative 0.005 is negative 0.005 t.
Okay, so that's your integrating factor. You're going to multiply it. But let me go back to my original question. So, Ruby, what Sam did was Sam brought the c to one side, to that side, and then put, he defined the differential equation in that term. Let me ask you this. What do you think can be like negative p plus 0.005c? Can we call that a function of c? So if that was like d by dt, can the right hand side be like y, a function of y? Emily, what do you think? Where I'm going with this, I want us to see if we can maybe solve it using separation of variables.
Okay.
Remember, P is even though it's a monthly payment, but it's a constant, it doesn't change.
so I guess from here you just integrate both sides, right?
So we just ignore this and just integrate this.
Well, correct. Well, you need to multiple, correct. But we're gonna get there. But let me ask you this: can you divide that original differential equation?
This one up here?
Yeah. Can you divide both sides of that by negative p plus 0.005c?
Oh
Sure.
yeah. Because
Okay.
this is a constant.
That's a constant, exactly. So if can you do that? Let's see where you can fit it. Can you do it?
What, maybe here?
Sure.
Okay, so you want to divide both sides, so that's basically going to become 1 over negative p, I hope I'm doing this right, plus 0.005c dc dt equals just basically 1.
Very good, okay.
So then we could integrate both sides.
So if that's dt, if you multiply both sides by dt, okay, can you rewrite that equation one more time?
Maybe.
Okay, good.
Oh, there's a. Oh, sorry. No, it doesn't look like I can.
You're good.
Okay, so we have 1 over negative p plus 0.005c dc equals 1 dt.
Okay, Emily, what do you think? Can we take the integral of both sides of that equation?
Yeah. So
Maybe up.
Sam, what do you think? Would it be simpler than using the integrating factor, or would it be the same level of difficulty?
I just know how to do this better, but it seems kind of the same.
Okay, very cool. Those are two different ways you can solve this differential equation. Which, if we do that, then we have done the homework for the people at home. So let's leave it as at that. And
Okay.
thank you all for contributing.
Yay. Alright. You're more comfortable with that, I'm